At question 9b from the 2015 National 5 Physics paper. It says that the stone reaches the water 0.80 seconds after it was released. Calculate the vertical velocity of the stone as it reaches the water and ignore air resistance. So clearly this child is throwing the stone horizontally, as it says in the question. So there's no initial vertical velocity. So the first thing we can do is we can say that u, the initial vertical velocity, is equal to 0. It's going to hit the ground, river, it's not a ground, after accelerating for a period of 0.80 seconds, and it's accelerating due to gravity. So its acceleration, or rate of acceleration, is 9.8 meters per second squared. So what we'll do is we will just try and answer the question by looking at the formula that we should use first of all, which is v is equal to u plus at. Now this formula states that the final velocity is equal to the initial velocity plus the acceleration times the time. Now bear in mind where I get that formula from. I get it from a rearrangement of the formula v equals v minus u divided by t. And when we rearrange that formula, we put it in this form, v equals u plus at. Now you can solve the problem by using this formula and plugging the numbers in here, but I'm just going to do it this way here. So let's finish off the question. What we're trying to find is the final vertical velocity. The initial vertical velocity, as we said earlier, is 0 because the ball was thrown horizontally, plus the at, with the acceleration, is 9.8 meters per second, and the time is 0.80 seconds. And so when we do that, we get a speed of 7.8 meters seconds, and the units are meters per second to the power of -1. I'll just put that in the right place because that's the units for speed. Notice that the significant figures I've chosen as 2 because we're given 2 significant figures for the time. And hopefully that clears that question up for you.